Hi, class. I am here today to talk about emotional behaviors, chapter 11. I'm trying something new with recording, starting my recording with the slide up and see if that works. I am going to talk about a couple of objectives here. I'm going to discuss emotion using the James Lange theory and emotional parts of the brain, and then I'm going to discuss the genetic and chemical effects on aggression. So first, objective one. We usually think about emotion and the way that the body reacts to emotion in a kind of common sense way. So here's our common sense view. We see a snake, we get scared, and then we have this autonomic nervous system arousal, the heart rate goes up, we start sweating and all of that. James Lange is a very prominent view in physiological psychology of how emotion happens. And there's a reverse in the last two processes. So what he thought, James and Lange, two guys, thought is that when you see a stimulus, your body reacts first. The heart rate goes up, you get real intense, eyes widen, sweating and all that. And then you feel fear. You feel fear on the basis of that bodily reaction. That's the idea here. So under James Lange theory, our experience of emotion is really just a label for the body response that we get. And there's some evidence for that. And I want to go over a couple of points of evidence there. One is a condition called pure autonomic failure. And that's when the autonomic nervous system fails. And so that people don't get that intense emotional reaction of the body. We don't get the sweating, we don't get the increased heart rate, we don't get the kind of shakiness and stuff like that. Well, what happens with people with pure autonomic failure is that they do report emotions, but they experience emotions as being weak or very mild emotions. They don't experience them in the way that you do when you have that bodily reaction. So that makes us think that, in fact, again, the bodily reaction is incredibly important to the experience of emotion. Therefore, it must come first. Another bit of evidence is that if you force the body into an emotional pose, meaning you act like you're having an emotion, it actually causes the feeling to happen. So we know from the pen experiment that you probably learned at some point or another in psychology is that just smiling actually makes us feel happy. And so just doing the pose with the body and giving people drugs, for example, like epinephrine that will make their heart rates go up and stuff like that, makes them feel more emotional. So the body, again, comes first, then the reaction. Botox on the face right here will tend to weaken negative emotions. So taking away that bodily reaction, that ability to frown, weakens your negative emotions. I need to get some of that right there. Let's talk about some of the emotional areas in the brain. For one, we have the limbic system. The limbic system is a group of structures that you've heard of before, the hypothalamus, hippocampus, amygdala, and cingulate gyrus. And those tend to be activated with emotional stimuli. So we think of those as an emotional area of the brain. The frontal and temporal cortices also are important for emotion. They're involved in both understanding and expressing emotional information. When we see frontal lobe damage, we see people that have very poor decision making. They're very impulsive, but they make decisions with almost no emotion. So it does mess up our decision making if we damage those areas. The insular cortex is an area involved with taste. We've talked about it before, I think, with regard to taste. But it's also involved with anger and the emotion of disgust. And so that area tends to be activated when we feel disgusted or angry. But in general, it's very difficult to, as usual, the brain kind of acts as a whole, and it's hard to get a specific correspondence to say that this specific structure is happiness or this specific structure is fear. It's happening throughout the brain. There are a lot of areas involved. Here you can see some of the components of the limbic system. They're deep in the forebrain there. Okay, I want to talk a little bit about hemispheric asymmetry, which means two sides of the brain being not the same. The right hemisphere seems to be involved in negative emotion more so than the left hemisphere. And so when we get damage to the right hemisphere, people have difficulty making or even recognizing fearful or sad expressions. They just don't. They get happier actually when you damage the right hemisphere. When you damage the left hemisphere, that tends to enhance depression, makes things worse, and enhance sort of emotional detection, the ability to see bad things in other people's faces and things like that. If you anesthetize, just anesthetize, meaning like numb it out, the right hemisphere, people will start to describe past events, even very disturbing events, without any emotion at all. They'll just talk in a very non-emotional way. And so we see also that there's asymmetry in different people. So some people have a kind of dominant right hemisphere and others have a dominant left hemisphere. And people with a greater activity in the right hemisphere tend to be more shy and withdrawn. And so we think of that as sort of a behavioral inhibition system. It kind of keeps us, the right hemisphere is kind of keeping us away from, you know, it's the emotions that's like fear and stuff like that gets us away. People with more activity in the left hemisphere tend to be more happy and also angry. So those are the emotions that kind of bring us toward. So people that are happy go toward others. People who are angry also go toward others. It's an activation system rather than an inhibition system. So in general, the left hemisphere is more kind of active emotions. Okay, we'll talk about the genetic and chemical effects on aggression. Okay, well, there's a bunch of different effects on aggression, and some of it is past experiences. For example, abuse, child abuse will tend to result pretty reliably in aggression. Lead exposure, same. Current physiological state, your hormonal state, your level of testosterone, for example, the neurotransmitters, we're going to talk about serotonin. There's usually also a pain or a threat that's involved in aggression. Aggression is a response to something in the environment. And then there's also a genetic predisposition toward aggression. So if you are born of a family that is aggressive, you're more likely to be aggressive yourself. So let's talk about that. Genetic effects on aggression. We know that aggression can be bred in, and anybody who knows the breeding of pit bulls knows that quite well. There are some species of dogs that are bred to be aggressive. Well, how do you do that? You just get aggressive male and aggressive female together, and then you have their babies tend to be aggressive, and you take the most aggressive ones, you breed those together, et cetera, et cetera. So aggression can certainly be selectively bred in the sense of dogs like that. We do see monozygotic twins, identical twins, be more similar in aggression than fraternal twins or dizygotic twins. Genes, however, will interact with environment on aggression. And so if you take a child who was the spawn of genetically aggressive parents or two aggressive parents, there doesn't really seem to be a big effect unless that kid is raised with a lot of aggression or in an unstable household. If the kid is raised in a stable household, the kid tends to do much, much better. So certainly there's an environmental effect that's important as well, but definitely some genetic effect on aggression. Well, surprise, surprise, which hormone is associated with aggression? It's testosterone. Most aggressive behavior is going to come from males during reproductive season in most animals. We humans do not have a reproductive season, but many animals will only breed for a few months out of the year. And that is also the time when males become very, very aggressive. So it makes sense that testosterone is going along with sexual activity and also aggression, so one can compete for mates. For men, from 15 to 25 years old, that's the highest time for testosterone. After that, it tends to decline very slowly over the course of a lifetime. But that is also when men are most aggressive, between 15 and 25 years old. Men who are more violent tend to have higher testosterone levels, but the correlation is small, and there are many men with high testosterone levels who are not violent, for sure. But it does tend to be a significant correlation there. Alcohol is a major factor in violence, and lots of studies from prison inmates have shown that alcohol use is associated with a tremendous number of violent activities. And that is because of the loss of inhibition that it provides. And so when we drink alcohol, it kind of numbs out or reduces activity in our prefrontal cortex. And that's where all the reasoning is done. And this is like, is this a good idea if I do this? And so all of a sudden that's all out the window and you're punching somebody in the face, right? We see the same kind of increase in aggression with people with prefrontal cortex damage as we do with alcohol. So clearly there's a loss of inhibition that tends to cause aggression there. Okay, I want to talk about serotonin and aggression in non-humans, and I'll talk about it in humans. It's really hard to measure serotonin because if you measure, you'd have to measure it in the CSF. You'd have to look at serotonin. As you probably remember, serotonin gets reuptaken. So we don't see the byproducts of serotonin too much. But what we do see is the amount of 5-HIAA, and that's how we measure serotonin basically. And we can look at it in the cerebrospinal fluid. We can also look at it in the blood. And what we see is that low serotonin turnover, which means low serotonin, is associated with aggression. And if you look at monkeys, what you find is those who are the most aggressive have the most scars, the most impulsive, and those who die young are those with low serotonin turnover or low serotonin. And so the question is this a generalized disinhibition of everything from the low serotonin? Does it really have to do with aggression per se, or is it just impulsivity like we get with the use of alcohol? Okay, well, we've looked at serotonin and aggression in humans, and what we found is that in prison populations, people with a history of violent behavior or suicide, because remember, serotonin is also associated with depression and suicide, those with a history of violent behavior or suicide tend to have low serotonin. And if you lower serotonin in people, now remember, we're always increasing serotonin with to treat depression, but if you lower serotonin in people, it tends to cause either depression or aggression, depending on what that person is sort of typically does. Are they aggressive people or depressed people? So there have been a lot of researchers that have started to gather around this idea of the triple imbalance hypothesis. And that's an idea that there's 3 imbalances that tend to lead to aggression. Any one of them does not cause great aggression, but if somebody has all 3 of them, then you start to get a tipping point where the person becomes very aggressive. And so it's low cortisol, and we're going to talk about cortisol when we talk about stress, low serotonin mixed with high testosterone is that aggressive cocktail. And so you don't tend to see women are ever going to have that because they don't ever get the high enough testosterone. So women don't tend to be as aggressive, and you can see with violent crime, women are just like down here and men are up here. But it's because the effects of any single imbalance is small, but the 3 of them together, that's a big deal. Okay, we'll hit the next objective on the next one. Thanks for listening, guys, and have a great